We should have always done it that way.
14 questions, not too horrible. 1 and 2, I believe, are true. Okay, rhymed. All right. You guys ready?
Yep.
Yep.
Number 3. Given the linear regression equation of y equals 2.0 plus 1.5x, what is the y-intercept?
2.0.
Yeah.
Yeah.
Yeah, it's definitely 2.0.
2.0. The slope is 1.5.
Yep.
Given the linear regression equation of y equals -3 plus 0.25x, what is the predicted value of y when x equals 16? 1, right?
Plus.
So
Wait, what did you say?
1? Sorry, not 7, 1.
How'd you get
So 0.25 times 16 would give you 4 plus -3, so positive 1?
Oh.
Or is that wrong?
No, that sounds right. Because you just solved for y. But I didn't see that that 3 was negative. That's like a really...
That
I was like, 7, no.
I was going, I don't know.
And then he can like do his mouth in his head. I like have to like draw it out and redo it 5 times before it's right.
Well, at least we're on the same team, right?
Yeah.
Yeah.
Algebra is always easy for me. It's everything else that I don't like. All right. 6. Make a scatter plot of the math self-efficacy data of the 3 data shapes in terms of key reading. Which shape best describes these data?
So how do you make a scatter plot again?
The data.
You go to graphs and then legacy dialog and scatter plots.
And then just the simple scatter.
Yeah.
And then which ones do I put where? So the confidence rating is the x-axis, and the score is the y? No, maybe?
It's a good question. Let me look.
Well, the way mine turned out, it definitely looks more like a weird hot dog. Maybe a banana.
Is that an option?
Yeah. It's too bad random dot isn't an answer, but so let me try it again and switch them up. So if I did this backwards.
That's free falling down.
I think a banana is still what I would go with. How do you guys feel?
A banana.
Because it's kind of curved.
I agree.
And a hot dog would be more straight, right? They should have just had pictures. I mean, you just picked the right picture.
Yeah, there you go.
And then when we get this one wrong, I'm going to say, you should have posted a picture because this is what my bananas look like, are these random dots.
So you put the score in the x-axis?
I tried it both ways, and they're both really similar. But so I did one was the y, confidence was the x, and then I reversed it. But they both look like bananas to me.
I wonder if I'm doing it right.
You want me to screen share?
Sure.
Yes.
It's the same as mine.
Okay, which one do I push again? It's the green one.
Yep. With the white arrow.
Hey, you guys ready?
Yep.
Oh, I'm not looking. That's probably a good idea.
Did you guys see it?
Oh wait. I don't know if mine kind of looks like that.
Okay.
And then there's the
Oh
other.
That's
yeah,
what
mine
mine
looks
looks
kind of
like.
like the bottom one, I think.
So this is the one where the confidence rating is the Y, and the score is the X, and then this one's the vice versa. Score is the Y, confidence is the X.
Mine look very similar to that.
But they both look like bananas. See how it's kind of like curved? I think a hot dog would be straight, but more narrow in the dots.
No,
See how-
the top one is definitely a banana, I would think. Like, I can definitely see that.
See, yeah. Pictures.
Yeah.
Oh my gosh, those.
I feel like we're taking I feel like we're taking an ink blot test here.
I feel like this is opinions. Just kidding.
Well, we talk for different ones and see how it goes. I'm gonna
What
put
if
banana.
that's how a banana looks like to me, or a hamburger.
I would just say I was really hungry at the time, so banana.
Yeah.
Banana sounded best, yeah. I just had a hamburger not too long ago, so it doesn't sound that great right now.
I know, I just had a massive dinner, which is why the banana is
So much healthier, yeah.
sounds light.
Yeah.
Okay, so we're good with banana then?
Let's go with banana. Banana.
Cool.
7. Based on the shape of the scatter plot you produced in question 6, what can you say about the appropriateness of using simple linear regression to model these data? Boom. Let's see. That's a good question.
I don't know.
2 point what would be best to even look at that?
I don't know. I'm looking through it, and I don't even know if it even talks about shapes and how they compare.
Well, I think that the more linear the data is, the better it would be for this type of analysis. So I would assume that if it's all over the place, that would probably mean that it wouldn't be great.
Hey.
Oh, look. So I found it. So 3, everyone go to 3, about the manatees and the powerboats. It shows a graph and then it says what it would or wouldn't be good for. So like the hot dog shape, which to be honest,
hot dog looks like ours.
yeah, so ours is probably a hot dog. It's a linear
I'm so
pattern.
glad we found that.
Convex regressive
Is
analysis,
that on the?
there is a significant linear relationship. So this is the only kind that would be appropriate for a linear relationship. So let's go back and change that answer. So we're going to say hot dog.
Hot dog.
Say that simple linear regression is appropriate
Okay.
because of how the shapes are spelled out. Don't you guys think?
Yeah, it says that it's appropriate.
The other ones
Sure.
are not appropriate. And that banana definitely looks like a banana.
Yeah, that one, no doubt. Hands down.
Well, good. I'm glad we found that.
Yeah, because that one's definitely a banana instead of ours, where it's like, if you turn your head and close an eye, you bet. That one.
For sure.
Yeah.
So, in order to get the next one, do we have to do that bivariate thing?
How many observations? Does it just mean the number of...
139 is what N is.
Yeah. So, 9. Questions 10 through 13, and the next one's 9. Use the math self-efficacy data to answer these questions. Be sure to use the confidence data for the explanatory variable and the score data as the response variable.
So how do we set this up, Justin?
Let me see here.
I love how he's our SPSS master.
Not really. So you got to go back in to whatever, and you got to set your for your scatter plot, and then
So we go to graphs, legacy
graph
dial
legacy dialog.
pattern. then you're going to do, what did it say? It said be sure to use confidence for the, well, so which one would that be then? Would that be X?
So your confidence.
Is that dependent or independent?
Oh, where did I write that down?
Mine says X and Y and markers and labels. Mine doesn't have anything about independent or dependent.
The independent variable is X, and the dependent
Yeah,
variable.
right there. Independent is X. So we're putting what's in the independent?
It just says explanatory variable and the response variable. So
Yeah,
the
those
response
are.
No.
Yeah,
right?
so you get those after
The
you run
independent,
the
the
test.
independent is explanatory. The dependent. So the explanatory is X, and the response is Y.
Yeah, and don't we get those after you run our test though, or no?
Response is Y.
I don't know.
Score is Y. Confident is X.
Okay. So confidence is independence and score is dependent.
Score is Y. Confidence.
Okay, so I don't even under. What was the question? What is the y-intercept? Mine is not a scatter though. How do you get it linear?
Don't you go to analysis and then regression and then linear, and that's where you get that, or no?
Oh, crap. So which one was dependent? Confidence? Right?
I don't remember.
Say that again.
Which one was dependent? Confidence or score?
Okay, so independent is also known as explanatory. Dependent is also response. So the explanatory is the X, and the Y is the response.
Why is
So explanatory is X. So explanatory X.
Wait,
Y.
let's take it. So I did this. Explanatory.
Okay.
So then X is independent.
So what were we trying to figure out again?
So the confidence rating mean, that's X and that's independence, correct?
I don't even know. We're trying to figure out the y-intercept.
Okay, so if we put
Y-intercept.
score in the Y and confidence in the X, if you double click on your scatter plot,
Okay.
and then let me see here. There is just above this new scatter plot that pops up. There's a little line going on a diagonal. Do you see that? With a bunch of dots around it.
No.
Yeah. Y equals 18.69 plus
Yeah.
12.69.
Yay! I figured it out
Yes.
too.
Yeah.
18.69.
Brilliant. That's awesome.
So is that? I mean, am I doing that correctly?
I got the same things. What is the slope?
So isn't that, oh,
12.69?
isn't that 12.695?
Mine doesn't say 5. How do I make it go out?
I don't know. Mine just says 12.69.
How does yours say 5?
I don't know.
I wish I knew how to bump it out a decimal.
Wait, so then 12.69 or 695, that was right underneath the 18.690, right?
Mine just shows it as an equation.
All right, quiz. Stop acting up on me.
I don't know how to bump it out a decimal, so we put the 5. I hate to miss it because of a thousandth place.
Yeah, I don't know how to bump it out either.
I think I'm just going to keep it as is. So what's the predicted value of y when x equals 4? Then we just solve for it, right?
So for that, I got 69.45. I don't know if that's. Let me know if that's what someone else gets.
So you just multiplied 4 times 12.69, right? And then divided or subtracted. I confused myself.
So my quiz just disappeared on me somehow, and it's a white blank page. Well, let me come back into it.
Yeah, it will.
Yeah, because these ones are grouped, you can come in and out.
Well, that's good news. That's that. All right.
Yeah, I got 69.45.
Okay.
Me too.
Wait, for your predicted y?
Yeah,
Yeah.
for 11. But we also got a different y than you, or the slope than you.
Wait, you guys just got 12.69, right?
Yeah.
Weird. Wait, so your equation shouldn't it be it's 18.690 plus 12.69 times 4.
Yeah.
And what did you guys get?
69.45. So it ended up being 18.69 plus 50 point something. 50 point something. I don't remember what it was exactly. 12.69 times 4 equals 50.76 plus 18.69.
Oh, I know what you did. Okay.
0.45.
Just kidding.
No, it's all good. We're all here together, right?
What? Okay, sorry. One more time. What did you guys get?
69.45.
Okay. Okay.
So, are we ready for 12?
Yes.
Matt, are you doing okay?
Yeah, I'm doing all right. Zoned it out.
Do you have all the answers still?
Yes. So we're on 12, correct?
Yeah.
Okay. You guys ready?
Yep.
All right. The confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for these values of x? The answer should be exact. So we just use the largest x value and plug it in to the equation?
I have no idea.
Yeah, I don't know what that's asking.
Yeah. That's
Or
weird.
do we use a scale from 1 to 6? And then so 6 would be the largest.
Well, looking at our data, we said that the confidence rating mean was the x-axis. So the largest x can be is 6.
Okay.
Like that's how far our graph goes. So should we just plug 6 in?
I think that sounds right.
So is it 94.83?
I got 94.83.
Perfect.
I really hope we're doing this right.
94.
Me too.
Me too. We'll see.
Because I know you can like go on and put a variable in the equation, and then it can give it out for you. So, but I don't know if they're actually talking about the highest score or if they're talking about like, oh, the reading. Okay, so it would be 6.
How many explanatory or independent variables are present in simple linear regression?
Sorry. How many explanatory variables?
Isn't there just one? Like, when you're doing a linear graph, you can only have one x.
Yeah.
It says simple linear regression, so I would assume 1. And how many dependent, so how many y's are present in simple linear regression? Wouldn't that just be 1 as well? Linear regression is x and y, right?
It doesn't say anything about that.
Well, in 4 it says sometimes it is necessary to use more than one independent variable to predict the value of a response variable. For example, if we want to predict stopping distance for a car on dry roads, we might want to use the initial speed of the car, the weight of the car, and the amount of tread on the tires to predict the distance required to slow. So that's talking about the independent variable. There may be more than one independent variable. But that's in a multiple regression. When we want to refer to simple linear regression, there are a variety of names that could be used. Simple linear regression, ordinary linear regression, simple, ordinary. If we need to distinguish between simple and multiple regression, okay, so multiple regression is not the same thing as simple.
So there can be multiple explanatory.
But that's not for simple. So the question was for how many responsive variables are present in simple linear regression. So that was for multiple regression. Let me see if I can find anything for simple. So regression allows us to write linear equations that have a relationship between x and y, or independent and dependent, which we predict the value of y for any given x. Sometimes the independent variable is also called the explanatory, yada, yada, yada. I think it's only 1 and 1. I think it's a trick for the multiple regression, because it even says what's in a name or whatever, and it talks about it.
Yeah.
I think it's 1 and 1.
I do too. Okay, you guys want to try this out?
We got an 81, but we got 12, 13, and 14 right. We did not get 10, 11, and 12 right.
Oh.
So probably 12.695, and then that would affect 11, which would then affect 12. Which really isn't fair because how are you supposed to get it to 3 decimal places?
Okay, so I know what we did wrong, and I got 100%. Sorry, I like waited. But okay, so when you do this, you have to go to analysis, and then regression, and then linear. And then you plug those in, and those will give you all of your individual numbers. And those ones are, and so they don't give you the equation, but you plug that in to use your equation. So that's why, because I did that, because that's what he did on the video. And so that's why I got 12.965 instead of 12.90 or 12.969. Yeah.
Well, I can live with an 81, but that's
Sorry.
good.
Wait, so where did you go again? Explain that
So
again.
you have to go to analysis, and then regression, and then linear. Because you're doing a linear regression, so that's how you have to do that.
And is that in analyze?
Yeah. It's like, yeah, it's like almost halfway down.
All right. Awesome. Hey guys, do you mind if I head out?
No, I think we're all
No,
done, right?
it's, yep.
Well, make sure everybody contributes to the final project stuff. I'm going to go ahead and post this video. So we'll be in touch.
Thank you so much.
Bye, y'all.
Awesome. See ya.